What's up guys, today on Dirt Lifestyle we're going to build some double shear high steer arms for my 1-ton axle swap. There's a bunch of different routes you can take with this. I personally really like the machined high steer arms that you can get. They're beautiful works of art, but they are very expensive and they're outside of our budget. I found a less expensive version online from Artec Industries and it runs about 230 bucks. This is way more affordable, but I was looking at it and I know that I can build something super similar to this for much cheaper. I buy all of my steel remnants from a local steel yard by the pound. They sell it to me really cheap, and I think that I could do this for less than 20 bucks. The basic design we're using can be applied to almost any steer axle, but today we're working on a Dana 60 from a 2004 Super Duty, and the first step is just to get everything cleaned up. We need to make sure that this is really clean because we're going to be welding onto these knuckles, and we're got to make sure that we have good penetration so everything sticks together. This axle is going to be going to my 2003 Land Rover Discovery, and I'll be building the entire steering system from scratch. I'm going to be using a kit from Barnes 4-Wheel Drive. It's Heim joints. This is how I prefer to build steering these days. So I would recommend that you get a hold of whatever steering components you're going to need before you template your high steer arms, because it's going to make it way easier to make things accurate and make sure that you have a good finished result. For this high steer setup, I pulled out a whole bunch of scrap pieces and I'm just gonna basically make what works. I'm using 3/8 or 1/2 inch for most of this. I drilled some 3/4 inch holes because we're gonna be using 3/4 inch bolts for all the hardware. 3/4 inch is extremely strong. I've never had an issue using 3/4 inch for this kind of stuff. So this Heim joint is gonna go on our Pitman arm for the disco. This Heim joint is gonna go for our tie rod. This one is for the other tie rod, and this one is for the drag link. So this one is going to mount up in here somewhere. I want to keep it pretty damn high. What my plan is to grind this away because this is for some weird vacuum stuff that Ford did and we don't need it. So I'm going to grind that away so we have a nice flat surface that I'll be able to fill with weld. We're going to have a plate that's going to come out right there. This is going to mount underneath it. I'm going to use some sort of a sleeve, probably with this DOM just because I have it laying around. Then I'm going to offset the tie rod. So the drag link is going to mount somewhere up here and it's going to go through this existing hole. We're going to put some kind of a sleeve in between here and here. We're going to make this double shear. We're going to have a plate that's going to go underneath it, a plate that's going to go on top of it, and then our tie rod is going to go out a little bit further. It's going to come out here somewhere. And the reason I want to do that is because I don't know exactly how much of a distance I'm going to have to clear this front cover. But a lot of times you have to bend the tie rod to clear the front cover, as I did here. So I have a little bend in this guy, and I have a little bend over on the other side, and that's to make sure I have enough distance whenever I fully turn one way or the other. I want to make sure I have enough clearance back here that these don't contact at any point. I also want to give myself some room in the future because, like you can see here, this has hydro assist steering, and I'm probably going to end up having to do the same thing in the Land Rover, so I want to have enough room for all that. This high steer arm is starting to take shape, and really all that's left here is going to be gusseting and welding. But before we get to that step, there's two things that I want to talk about that you need to factor in whenever you're fabricating something like this. One is, don't forget the size of your rim. It's a huge factor. Now you can take an offset of your wheel and you can push it way out to try and clear all this stuff, but it's just a good idea to try and build all this to where it's fully encompassed inside the size of your rim. My rim is going to be 18 inches. I don't have one here, unfortunately, but through the measurements that I've taken, this should clear that rim no problem. The second thing you need to consider is your pitman arm. The measurement from this hole to that hole are very important, and they need to correlate with the measurement of this hole to this hole. Now remember, this is our drag link. It's going to be pivoting off of our ball joint, and that measurement needs to meet the same as our pitman arm, because whenever you turn lock to lock, you want to make sure that you're getting the full amount of your steering. If you have a shorter pitman arm than you do the length of from this hole to this hole, it's going to make it to where you're going to turn all the way lock one way, and you're still going to have a lot left that you could turn in your axle. So those are really important ratios to keep in mind whenever you're designing something like this. I got extremely lucky. I measured, it was about 7 3/8 from this hole to this hole. I went over and checked the Land Rover, and it was about 7 3/8. I got so lucky. That's why I designed it to where I can use one long bolt basically from the drag link all the way down and through here. It works out perfect for me. But depending on what your swap is, or depending on what your steering setup is, you might have to adjust this drag link around. You might have to move it closer or move it farther away, or you go to a junkyard and you can find a pitman arm that fits your application, whatever you choose to do. But these are things that I think are really important to keep in mind, and stuff that you just don't want to forget about whenever you're designing something like this. When you're designing and assembling your high steer setup, I highly recommend not to finish weld anything until you're completely done. So as you noticed, I just go through and I tack little bits here and there just to keep things in place to make it easier to design. But whenever you start to finish weld things, they're gonna warp on you and they're gonna change shape. If you have your gussets and everything taken care of first, it's way less likely things are gonna warp on you. As you're tacking, I recommend putting your heim joints in place and keeping them there all the way up until you're just about to start welding. Then you can remove them, they're out of the way, you're not gonna cook them, but while you were assembling everything, it helped keep your clearances right. So hopefully once you're all done welding it all back up, these are gonna fit back in place and you're gonna have no issues. We've made it to the most important step of this entire process, and that is finish welding. We're gonna be welding mild steel to cast steel. And I've seen conflicting arguments on whether or not you need to preheat in order to do this, but we're going to. We're gonna heat this up to 450 degrees. Everyone agrees it needs to cool slowly, so we're gonna make sure we do that with a torch, and we're gonna wrap it in a blanket once we're all done. I'm gonna be heating everything up with MAPP gas. MAPP gas is cheap. This double-ended torch works really well for this kind of thing. And if you don't have an infrared thermometer, you need to get one. They're really inexpensive, and they're so handy for a project like this. One other tip I can say before you weld something like this: not enough people take lighting very seriously. I think getting yourself a decent set of lights is so important, because even with an auto darkening helmet, some bright lights really help illuminate the lines while you're welding and make it so much easier to figure out where the hell you are when you're burning all this together. All right, it's been a little bit over an hour. Let's see what kind of temperature we are running underneath this blanket. So let's see, we're at, this is 213. So it's still pretty warm. I'm definitely gonna get this wrapped back up really quickly, but I wanted to show you guys basically the finished results. I mean, it was super simple. I just welded the inside and outside of everything. This is half inch, 3/8. It's all heavy duty. It's definitely not going anywhere. I don't want to paint these or anything for quite a while, because I'm gonna wait and do all that after I have it fitted to the Rover. I want to make sure there's zero clearance issues, because this is something that, you know, I built it. I can still fix a clearance issue if there is one, but I don't want to do a bunch of work to paint it and finish it before I do that. So this is something that's going to be going on the Land Rover. I'll be building the full steering system and everything in the future. I hope you guys enjoyed the video. If you want to see the rest of this 1-ton axle swap into this Land Rover Discovery, including suspension, finish up this steering system, all those kinds of details, make sure you like the video and subscribe to the channel if you haven't already. If you want to help support the channel, you can go to thedirtlifestyle.com. We have a link to our Patreon account. We have t-shirts, hats, stickers, all kinds of things like that. If you want to follow me on social media, I'm at DirtLifestyleNate. We'll see you next time.